Estimation. We can predict the y value for a given value of x. But one warning is that you do not want to estimate a y value, the response variable, unless the value of your x variable, the predictor, is in the range of data you use to create your line of best fit. This is very dangerous to do, and you should avoid making that mistake. This is something called extrapolation. You can think of the prefix extra as meaning outside of. So you're making a statement outside of the range of values you have information about. After you have found that x and y are correlated, so you must do the hypothesis test first, then you may predict as long as you do not extrapolate. How much would a wolf weigh if the tail length for that wolf was 16 inches long? First, check to make sure that 16 is not extrapolation. In this case, 16 is within the range of the data, so we are fine to make an estimate. We begin by traveling up to the line from where our predictor value of 16 is located. Then we want to go over and find what weight corresponds with that x value. In this case, we want the y value of weight. In order to do this, what we would think to do is use the equation of the line to get the estimate. So plug that value of 16 in for your x variable. So weight is 48.4 plus 2.5 times 16, or 48.4 plus 40, or 88.4. So on average, we might say that a wolf that has a tail that is 16 inches long, we would estimate is going to weigh about 88.4 pounds. But do we really estimate values in statistics with a single number? Hopefully your answer is no. How would we provide an interval estimate so that we have more confidence in the statement we're making? Well, this table from software, specifically StatCrunch in this case, gives intervals for predictions. Now you will notice two intervals. One is a CI, or a confidence interval, while the other is a PI, or a prediction interval. And the question should be, what is the difference between these two? Well, there are two possible estimates you might be asked for. One, you wish to estimate the weight for one wolf that has a 16-inch long tail. Or, number two, you may wish to estimate the mean or average weight among all wolves who have 16-inch long tails. This is similar to normal probability you worked before. For example, what's the probability one can of soda has more than 12 ounces in it versus what is the probability a random sample of 10 cans have a mean of more than 12 ounces. Two intervals, the PI or the CI. So you wish to estimate the weight of a wolf, just one wolf, that has a 16-inch long tail. This is called a prediction interval. It's a prediction for one observation of a wolf's weight that has a tail length of 16, and this is not one of the wolves in your data set. So you're sort of estimating, if I went out and I found a wolf with a 16-inch long tail, how much would I estimate that wolf weighs? Number two, you wish to estimate the mean weight among the population of all wolves that have 16-inch long tails. This is a confidence interval. So think about estimation when the tail length is 16 inches. Notice the x value or tail length of 16 is on the first row of values in this table. Now the 95% prediction interval for new is 52.2 to 125.2. So I could write a summary that says we are 95% confident the weight of a wolf, because remember this is for one, that has a 16-inch long tail will be between the two values, 52.2 pounds and 125.2 pounds. In the next case, we look at the 95% CI for the mean. Interpreting this interval, we would say we are 95% confident the mean weight of all wolves that have 16-inch long tails will be between 75 pounds and 102.4 pounds. Consider visually what is going on with our intervals. The CI for the mean was 75 to 102.4. It's estimating the mean when the tail length is 16. That would be this interval that stretches from the lower weight of 75 up to the upper weight limit of 102.4, and that would be the mean for all wolves with 16-inch long tails. Now the PI for one wolf, there's a lot more variability in the weight of a single animal than the mean of many animals, so this is going to be much more spread out. It ranges from 52.2 up to 125.2. So it might look like this. Notice that the prediction interval is much more spread out than the confidence interval. Now, suppose you are asked to estimate the mean weight of wolves that have tails which are 30 inches long. What would your answer be? "30" is the bottom row of this table. Now consider our data again. What is the first thing you should do when asked for an estimate? Did you check the scatter plot? Where would 30 inches be located for a tail length? Well, it turns out it's not on our graph. It would be off to the right somewhere. So 30 inches is longer than any of the data in our sample. So it would not be appropriate to provide this estimate, and that would be your conclusion. Now suppose you are asked to estimate the mean weight of wolves that have tails which are 24 inches long. 24 is the middle line in our plot, and this is actually okay to provide the estimate. You need the confidence interval since you're asked for the mean weight of all wolves, where X, the tail length, is 24 inches. So you want to interpret 95.2 to 122.6 for the scenario. Remember, in a confidence interval interpretation, you want to give certain information. Number one, the level of confidence. Number two, what you're estimating, and then the bounds for the interval. So I would say I am 95% confident the mean weight of all wolves that have 24-inch long tails would be between 95.2 pounds and 122.6 pounds. So this is the way you would do estimation in simple linear regression.